Every January, corporations lock in an annual budget. For the first quarter, the math holds up. But as the year progresses, market realities diverge from the initial spreadsheet, and the structural integrity of that static plan begins to fail. A calendar-bound plan assumes a highly predictable world. When a sudden supply shock hits in October, a budget written the previous November is worse than useless. It is actively misleading. This creates a severe operational paradox. A factory requires absolute stability this week to run efficiently, yet the broader supply chain must remain highly responsive to massive, unpredictable shifts happening next quarter. The solution requires abandoning isolated annual events. Planning must become a continuous, decision-driven process. True operational agility requires a system where planning never stops. It constantly ingests new data to operationalize the company's long-term strategy. This methodology is called rolling planning. It is a structural framework where plans are reviewed, updated, and extended forward on a strict cycle. As one month is consumed by execution, a new month is appended to the back end, maintaining a constant planning horizon. This continuously pushes the horizon forward, avoiding the December blind spot of zero visibility. As time flows through this structure, the nature of the plan transforms. The near-term elements harden into firm execution orders, while the long-term elements remain flexible probabilities. A simple forecast is merely a data input predicting what might happen. A rolling plan is a cross-functional decision framework dictating how the business will respond. The objective is not to predict the future perfectly. The goal is to deliberately balance systemic stability against necessary flexibility. The mathematical logic of continuous extension works exactly the same way regardless of the timescale being measured. At the microscopic level, a master production schedule operates on a tight weekly rolling cycle. In this framework, the immediate 1 to 4 weeks are strictly locked in for execution. The weeks further out remain adjustable to absorb new demand signals. Zoom out to the macroscopic level, and sales and operations planning applies the exact same concept over a rolling 18 to 24-month horizon. Every single month, the S&OP process uses this extended horizon to continuously rebalance capacity constraints, inventory targets, and supply plans. Corporate finance undergoes a parallel transition, replacing rigid annual budgets with continuous rolling financial forecasts. Whether measuring in weeks on the factory floor or years in the boardroom, the logic of continuous extension is identical across all business functions. If everything is constantly updating, a supply chain will quickly tear itself apart. We need a specific structural architecture to control the flow of changes. This diagram illustrates a rolling horizon scheduling strategy. Looking at the top layer, we establish our baseline timeframe. The red control horizon block represents the frozen zone. This is a strict time fence where no changes are permitted, protecting near-term execution. The yellow scheduling horizon, extending beyond that red block, represents the slushy and liquid zones, where flexibility mathematically increases further into the future. When a regular review cycle occurs, these iteration arrows show how the entire plan shifts down. Notice the horizontal shift from Horizon 1 to Horizon 2.
As time advances to the right, the overall duration of the yellow bar remains constant. Dropping down to Horizon 3 demonstrates the infinite, continuous nature of this forward-looking data structure. A primary misunderstanding in the industry is that rolling planning requires revising every single detail all the time. Only the unfrozen segments, the liquid zones sitting months or years in the future, are subject to significant revision. This specific visual architecture protects the supply chain from operational chaos today while maintaining the capacity to pivot strategically tomorrow. These mechanical time fences are grounded in the core methodology of Apex and Oliver White. The foundational rule is that decisions improve as temporal uncertainty reduces. You lock in a choice only when you have the data to support it. Therefore, long-term plans within this framework are treated as hypotheses to be tested, not rigid promises to be blindly executed. The friction and realities discovered during ground-level execution feed directly back into the next planning cycle. This feedback loop creates a system where every execution cycle directly informs the next planning phase, turning the rolling horizon into a self-correcting mechanism for the business. In many complex environments, adopting this continuous framework is mandatory for survival. It is critical for managing volatile demand profiles and actively controlling global inventory risk. It is equally vital in constraint systems, particularly when mapping capacity requirements or orchestrating complex new product introductions. But this system faces a severe internal threat, known as planning nervousness. When management frequently overrides the established frozen zone, that sudden change acts like a jammed gear, sending destructive, stuttering friction down the entire supply chain. Poor data quality or a lack of cross-functional alignment usually forces planners to break these time fences. Rigorous, uncompromising discipline and respecting the control horizons is the prerequisite to realizing the benefits of the model. The mechanics of rolling planning are currently evolving beyond simple spreadsheet extensions. We are seeing a rapid shift toward AI-supported demand planning engines, capable of processing massive sets of volatile variables in real time. This diagram outlines the steps to create a rolling forecast. Looking closely at Step 6, we see the absolute necessity of rigorous data validation. Moving to Step 7, scenario-based planning is built into the rolling horizon, allowing teams to test multiple future states simultaneously. Modern rolling plans no longer produce a single-path forecast. They act as robust, multi-variable scenario engines. To lock in this structural model, let's review the core mechanics. First, you must clearly distinguish what is locked versus what is fluid. The near-term execution window is rigidly frozen, while future periods remain mathematically flexible. Second, you must identify the primary trigger for updates. The plan rolls forward on a strict, regular cycle, not ad hoc reactions to daily emergencies. Finally, you must understand how this framework reduces overall risk. It eliminates the blind spot of an expiring annual budget by maintaining a constant forward-looking horizon. Rolling planning succeeds because it accepts a basic truth: uncertainty is a constant. Therefore, the act of planning must be continued.